Here's how to factor using sum and difference of cubes. So here's our first example. We need to factor this using the sum or difference of cubes. But what do those even mean? Well, first of all, to be able to use sum or difference of cubes, these two parts here in the problem, they have to be cubes for you to use the rules of cube. And a number is a cube basically if you can multiply three of the same thing to get to it. So like, for example, 64 here is a perfect cube because if you multiply 4 times 4 times 4, you will get 64. Also, like, for example, 2 times 2 times 2, that's a perfect cube because that gives you 8. And then 3 times 3 times 3 is 27. So 8, 27, 64, those are all perfect cubes. But it doesn't just have to be a number. For example, x cubed, x to the third, that is also a perfect cube, even though it's not a number, because x to the third just means x times x times x, which is a perfect cube. We're multiplying x 3 times to get x to the third. So because these are both perfect cubes, we can apply one of these rules. So first of all, I'll go over sum of cubes and then difference of cubes. So sum of cubes basically says that if you have a cube plus another cube, that's actually what we have in this case, a plus, then you can turn it into this. You can turn it into a plus b times a squared minus ab plus b squared. Now, difference of cubes is what you would use if you had two cubes with a minus sign in between. So we're going to call that a cubed minus b cubed. And that is going to equal exactly the same thing, except we're going to replace this with a minus and this with a plus. We're just swapping these two signs. So you would get a minus b times a squared plus ab plus b squared. So for this problem, x cubed plus 64, this is a sum of two cubes because the sum means you're adding them together, right? So we're going to use sum of cubes in this case. But we need to figure out what a and b are because we have a cubed plus b cubed. But a is not going to be x to the third and b is not going to be 64 because we need to figure out a and b, and they're going to be the numbers that we multiplied to get these cubes. So for example, for 64 here on the right, we multiplied 4 times 4 times 4 to get to 64. That's why it's a perfect cube. So b is actually going to be 4. And for x cubed over here, this is a perfect cube because we multiplied x times x times x. So in this case, a is going to be x. So all we need to do is replace a and b with x and 4 in this formula. So we're going to have a plus b, that's going to be x plus 4. And then we have a squared, that's now x squared because a is x, minus a times b, that's x times 4. You can't multiply a letter and a number, so it's just going to stay x times 4. Or usually in algebra, we put the number first, so that would be 4x. And then plus b squared. B in this case is 4. 4 squared means 4 times 4, which is 16. And there we go. We have now successfully factored x cubed plus 64. And remember that factoring is the opposite of simplifying. So if you saw this and you were like, oh, wait, I need to simplify this, right? You would just get yourself right back to here. So we're basically doing the opposite of simplifying. All right, here's another example. What are we going to do in this case? Well, this minus sign might suggest to you that we're going to use difference of cubes, which makes sense, right? And we've got x cubed and y cubed here. So they're probably perfect cubes, right? But the numbers in front also need to be perfect cubes. In this case, 6 is not a perfect cube. And if you didn't already know that, there's an easy way to tell. You can just figure out what the actual perfect cubes are. So in this case, we have 1 times 1 times 1. That's a perfect cube. That gives you 1. And 2 times 2 times 2 gives you 8. 6 is in between these. So that means that it's not going to be a perfect cube because 1's a perfect cube and 8 is a perfect cube. And 4 is also not a perfect cube. It is a perfect square because 2 times 2 is 4. But a perfect cube means you have to multiply 3 times to get that number. And there's no number that you can multiply 3 times to get 4. I mean, it's probably like a decimal or something, but we're not doing decimals in this. So if they're not perfect cubes, what do? Nothing. Now, if you literally couldn't factor it any other way, then you would just say that this is prime. And that would be your final answer. If it's prime, that means you can't factor it. But we can actually factor this another way, and that is, I'm noticing that 6 and 4, they both have 2 in common as a factor. You can divide 2 out of both of these. So what I'm going to do is I'm going to put 2 on the outside, and then I'm going to divide both of these numbers by 2. So 6x to the third now becomes 3x to the third, and 4y to the third becomes 2y to the third. And this is called factoring using the greatest common factor, or GCF. That doesn't have to do with sum or difference of cubes, but it is a thing you can do. So if it says to factor using sum or difference of cubes, that's not what this is. This is basically the only way we can factor this. You cannot factor this using sum or difference of cubes. All right, here's another example. What I'd like you to do for this one is go ahead and pause the video, try to solve this one for yourself, and then unpause and then see how you did. And this one's a little bit tricky, but try your best. All right, so let's see if these are perfect cubes, right? So 2 times 2 times 2, that was 8. And 8 is a perfect cube. But 3 times 3 times 3, that's going to be our next perfect cube, is 27. And 16 is not there, right? So 16 is not a perfect cube. And if we were to go on with 4 times 4 times 4, that's going to give us 64, not 54. So 54 is not a perfect cube either. So it looks like we can't use sum or difference of cubes, right? Oh no, how unfortunate. So I guess in our sadness, let's go ahead and factor this using the GCF like we did before. We could divide 2 out of both of these, right? Because they're both even numbers. So I'm just going to factor out a 2 and just say that we're done, right? So we're going to divide this by 2. 16 divided by 2 is 8. X to the third minus, and then 54 divided by 2 is 27. Y to the third. Oh, look at that. It magically makes a perfect cube, right? 8 is a perfect cube because that gives us 2 times 2 times 2. And 27 is a perfect cube because that's 3 times 3 times 3. So we can now use difference of cubes on this problem. So we need to figure out what A and B are, right? Well, here we already figured out that 8 is 2 times 2 times 2. But A isn't just going to equal 2 because we also have an x to the third here. And remember that x to the third is x times x times x. So that's also going to be attached to the A. So A is 2x. And if you weren't sure of that, you could test it out like this. 2 times 2 times 2 is 8. And x times x times x is x to the third. So that would give you 8x to the third. And now what is B? We're going to get B from this, right? We already figured out that 27 you get by doing 3 times 3 times 3. So we're going to have 3. But we also have a y cubed here. And you get that by doing y times y times y. So we're also going to have y here. So that's going to be b equals 3y. So now all we need to do is replace a and b in this formula. And remember, we're using difference of cubes this time because we have a minus sign. So we're going to replace a and b with 2x and 3y. And don't forget this 2 right here. This 2 is still in the equation. So we're going to have 2, and then we're going to do all of our replacements. So we're going to have a minus b, that is now 2x minus 3y. A squared, that's 2x times 2x. So let's go ahead and write this out. Remember, we multiplied the numbers and the letters separately. So 2 times 2 is 4, and x times x is x to the 2, or x squared. So we're going to get 4x squared. Now a times b, we have 2x times 3y. 2 times 3 is 6. And x times y, well, you can't multiply those, right? So it's just going to stay as xy. And then b squared, that's 3y times 3y. 3 times 3 is 9. And then y times y is y squared. So this is our final answer. This is the factored form of what we have up here. So you now know how to factor using sum and difference of cubes. But I also used GCF in this. And there are other ways to factor too. So if you want to go over all the different ways you can factor, you can watch this video right here. And as always, if you have any questions about this, go ahead and leave it in the comments and I'll be sure to answer your question. Thanks for watching.